Ha! Surprise! This isn't an intro. It's just me saying, hey guys, if you haven't checked out the video before this one, the first one in this series, you should probably do so because it covers a couple of things that are a little bit important. Alright, that's me done. I'll get out of your road. All yours. Intro coming now. Alrighty everybody, let's get started. So I'll just show you what I have set up already. I'm going to try and keep this tutorial fairly quick for you, see how we go. I've got a big flat cube that I'm just using for the ground. There's nothing particularly special about it, and I have a green sort of material that I've applied to it. It can be whatever you want, whatever, doesn't matter. Big flat cube for the ground. I've got an empty game object here that I've called block manager. That's going to do pretty much everything. We're going to attach our scripts to that. It's just empty, there's nothing else to it. The name doesn't matter at all, or layer, tag, whatever, that's all just default. It's just an empty game object. I've got the directional light, etc. And I've got a player object which I have the camera childed to. Now the player, I've got a controller script attached to. I'm assuming you'll have your own player controller, but if you don't, this script, I'm not going to cover it. What I will do though is put it up on GitHub, and I'll put a link in the description to this video. So if you don't have a controller, feel free to use that one. It's not very good. It doesn't jump or do anything too fancy. It just sort of moves around back, forward, left, right, and sprints. I'll give you a quick look at that, just so you can sort of see. Yeah, there you go. Oh, he moves pretty fast. Whatever. It's just for demo purposes, but yep, feel free to use that if you want to. I've also got two prefabs that I've created. They are just cubes at this point, default material, nothing really changed about them. I've just called one block placed. That's going to be the prefab that we use for our placed blocks, or the blocks that we put in the world. And I've got another one that I've called block template, and this is just going to be the prefab for the template block that you might have seen in the first video, the little blue one that we use to determine where we're placing blocks. I'm using two prefabs to split the layers up. You don't necessarily have to do it this way, it's up to you. It's just how I'm doing it. I've got some saved scenes, but they're not really important, and I have two scripts here that will create two C# scripts. One of them called block system, the other called building system. They're both empty at the moment. We are going to write those. So nothing too fancy about it. A lot of this can be whatever you like. I'm guessing you've already got something in mind, or you've got your own game, or whatever. You can have this however you like. There's a couple of key things, but we will cover those as we go. Alright, so first thing we're going to do. Now we're going to be creating a little block placement sort of system, as you saw. So the first thing we'll do, similar to the 2D tutorials, is we're going to create a system to create and assign the materials to the blocks. So I've created, what have I got? I've got 4 materials down here that I'm going to use for the blocks themselves. 2 brown colors, a green and a red. I don't know, just felt that was appropriate. I've also got a material for the template block itself. So that's just a little transparent material, that's the word, with a blue color. That's just got the alpha value turned down a little bit. Once again, you can just sort of use whatever you like. It's just for demo purposes. Alright, cool. Let's have a look at the block system script. So if you haven't created that one, create it now. C# script block system, or whatever you want to call it. We're going to get around to writing that. So this system, or this script, is going to be responsible for creating the block types and holding the data about what sort of blocks we want in the world. So if we want a wooden block, a dirt block, etc., this is sort of where we set all that up. So if you've done the 2D tutorial, you'll be familiar with a lot of this. We're going to be repeating a couple of the similar things, but one key difference is that we're going to use a dictionary for this, which is very similar to a hash table, I believe. I'm not sure if they're the same thing or considered different things, but essentially what a dictionary is, it's like a list or like an array. It's going to store a whole bunch of different, or a whole bunch of variables for us. In this case, they're going to be our blocks. And the cool thing about a dictionary is that we can assign an ID to each of those things. So similar to how an array would have an ID to identify the element in that array, we could assign whatever we want, and we can use that ID to be able to reference the object, and we can pull that object out of the dictionary when we want. And the good thing about these is that they're a lot more efficient than using lists. They're a lot better than using arrays, and if you need something specific, it's a lot easier to find it in a dictionary than it is in an array or a list. You won't really have to iterate through it. You can, but it's just easier to just grab what you want, and in this case I think it's going to be perfect. Now it's there's probably better ways to do this. I'm probably doing things a little bit strange, like I'm using an int. I'm going to use an int to identify the blocks in the dictionary, which ultimately is no different to using an array, but I'm just putting this in here mostly just to show you guys how it works. As always, you know, it's up to you guys to take these things away to your own projects and make them work best for you. So we'll get started. First thing we're going to want, actually before we create any variables, we're going to want a struct to store our block types, something to store our material and the name of the block. So we'll just create that under the block system class. So public struct block type, we'll call it. So it's going to be our types of blocks. I hope that makes sense. We're going to create a public string. We'll call it block name, and a public material, which will be block mat. There you go. So the block's material. Nice and easy. That's all we really need at this point for each block type. I mean, if you were actually building something like this, you could probably attach more data here to it. I don't know, different things. Is it solid? Is it not? Whatever. But at this point in time, we don't really need any more than that. One other thing, we need to mark it as serializable. I love that word. So much fun to say. But that will allow us to what will allow us? It will allow us to expose this struct to the editor as an array, and just make our lives a little bit easier. So now that we've done that, we're going to need one more class, and that's going to be for our blocks themselves. So the block type is, like you can see, the name of the block and the material, but the block class is going to store pretty much the same things, but we're going to use it to also store a couple other references, and I don't know, you'll see how it all works. So we're going to create another class now. Public class block. So we've got block type and we've got block. Public int, and that's going to be the block ID. We'll have a public string, going to be the block name, and we will have a public material, which is going to be the block material. Cool. And we'll create a class initializer here, int ID, material mat, getting there, 1 second. And essentially, when we create a block, we just want to assign, what am I doing? Block ID equals ID. We're just assigning all these. Name. And block material is going to equal mat. Cool, so when we create a block, we're just basically giving it that data and setting it up. Nice and easy. So we've got a public class for the block, and we've got a struct here for the block type. So we're going to use the struct first. That's probably going to be the easiest way to do it. And we'll set up the array to allow us to do that. So we'll create it as a, I think we only need it to be private. So we'll say serialize, not serializable, serialize field, so we can see it in the editor. Private block type array, all block types. Cool. So we're just going to use that. It just allows us to set the blocks up in the editor, basically. It's not really for anything other than that. It just makes our lives a little bit easier. You'll see why. And I'm going to do a hide and inspector because I want a public, and here we're going to get the dictionary. So a public dictionary. Oh, and one key thing I should probably mention, I think to use dictionary you need using system at the top here. You need to make sure you've got that there, or it probably won't work. Sorry, I added that a little earlier. So when we create the dictionary, the public dictionary here is going to have a key. The key is going to be an int, and the value is going to be the block. So we're going to be using the dictionary to store blocks or different block objects, and we are going to reference those block objects using an int, the key. So we have a key and a value. So we're going to call this dictionary, I don't know, all blocks. Seems good. we've got all block types and then all blocks, and it's just going to equal a new dictionary. There we go. So that just makes sure that it's ready to go. Alrighty. And I think all we want this script to do, other than holding all this data obviously, is create the block types for us when it starts. So we can probably just do that in awake. Awake, there it is. Private void awake. And we can just easily do a quick little loop for int I equals 0 while I is less than all block types dot length. So for every block type that we've set up in this array, this loop is going to run once. Increment I. Okay, cool. Let's set up the blocks. So we'll create a new temporary block type. There we go. Block type. We'll call it new block type. Sounds reasonable. And it's going to equal all block types I. So we're just going through that array, and we're going to create a temporary one here to grab some data from. We're going to create a new block. We'll just call it new block. So block, new block is going to equal a new block. That was fun. And so now we're going to pass the parameters down to that function. So the ID is going to equal I. So in theory, the ID of each block is going to increase 1 each time that we create a new one. And the name of it is going to be the new block type dot block name, and the same with the material, new block type dot block mat. So we're just creating this block, giving it an ID, assigning it a name, and assigning it a material. And we're getting that data from that array that we've created. So we'll set all that up in a second. So it doesn't make a bunch of sense, it will in a moment. And the next thing we're going to do is now assign that new block to the dictionary, which is really easy. We just say all blocks I, so we're giving it that key, the key that we want to use is going to equal new block. So it's similar to an array in that regard, I guess. You're sort of, but rather than referencing the, what would it be, the number, the element number within the array, the order of it, so that I in this case, it could be element number 1 in the array, it could be element number 2, whatever. That I, the ID we pass it, will always still be relevant to the same object. So perhaps another way to put it, another better way to put it would be, if we have a block type in there and it's in position 3 within the array, and we within the dictionary, sorry, and we add a few more things, and it becomes position 10, but its ID is 5, or the I that we're using, the int there is 5, it will always be 5. So whenever you reference it, so if you say all blocks I, that being 5 is equal to that, that's going to be the key that's assigned to that object, rather than its position within the dictionary. So it's just an important little thing to point out and differentiate between. We might just add a quick debug log statement here so that we can ensure this is working correctly. And we'll just say something like block added to dictionary, and what will we put after that? And we'll just say all blocks I dot block name. So that'll just ensure that if anything weird goes on, it should tell us what's going on, and we should be able to see that it's actually creating everything that we want. So save all that. I'm just going to go back into Unity quickly. I'm going to go to my block manager object, and we're going to assign that script. No, block system, that is it, that's the one we want. Cool, so I've got 4 block materials, so I'm going to create 4 block types in that array. What have I got? I've got 2 browns, a green, and a red. So we'll say, I don't know, the first brown could be dirt, the second could be wood. We'll make the green one grass, and the red one can be brick. And we'll just assign those materials. So what have we got? 2 browns. I'll make the light brown the dirt, the dark brown can be the wood, green is grass, and red for brick. Cool, that easy. Now if I run it, not a lot's going to happen, but you will see it sort of create them down in the console here. So there you go. So we've created 4 blocks, and we can sort of see that's working correctly, that the names are assigned correctly: dirt, wood, grass, brick. We can't really see any more than that at this point in time. So we're going to create the building system. This is the fun stuff. Yeah, cool. It's going to be awesome. You watch. Just bring that up. So the block system's pretty much done. We're happy with that. The cool thing is as well that we have this dictionary sitting here and it's public. So we can just reference this whenever we want from wherever we want, and we can get blocks as we need. And the thing we need to, or basically all we need to remember is just that ID. So if we, each block's going to have an ID attached to it of some kind, and this is where it gets a bit clever. Like if you wanted, you could probably even just use like a string or some sort of other variable to make it a bit easier. I'm just using an int, but yeah, you have an ID attached to each block, and as long as you know that ID, you can get a block whenever you want it. So we'll do the building system. This one's going to be a little bit longer, and it's going to have quite a few things. So we're going to probably be firing a raycast from the camera in this context. I have a first-person camera, so that sort of seems reasonable. So we'll want to store a reference to the camera itself. So we're going to have a private camera. We'll call it player camera. And we'll want a couple of balls as well to control the flow of the building system. So we'll say private bool build mode on. We'll just set it to false initially, and we'll create another one, can build, and we're going to do the same with that. Alright, cool. We also will probably want a reference to the block system script as well. I'm going to attach it to the same object, so I think I'll set that up now. We'll say private block system. I'm just going to call it bsys. That'll do. And I'll quickly private, that's what I want, void start. Just in the start function, I'm just going to assign that real quick. Whoops, what did I call it? Bsys equals get component. It's attached to the same object, or it will be, so that will make life easier. There we go. Alright, cool. How do we want this to work then? So there's probably going to be a few things we need to do. Like I said, we're going to be firing a raycast. So I think the first thing we'll want to do is actually toggle the build system on and off. That's probably going to be the best way to start. So we'll do that in update. So if, and I don't know, I'll do it via the E key. So if input dot get key down E. What are we going to do? So we'll toggle, first of all, we're going to toggle that build mode bool. So basically that's just going to turn it off and on. And another thing we might do as well is just to make sure it plays a bit nicer. So if build mode is on, we're going to lock the cursor and hide it so that it's not sort of interfering. And we're just going to do that by saying that the cursor's lock state, so the cursor.lock state is going to equal cursor lock mode.locked. So that all that does is just hides the cursor and locks it to the center of the screen. So if build mode is on, the cursor is locked, else do it again, cursor lock state is going to equal cursor lock mode.none, which is just going to return the cursor back to its normal state. So that's just locking and unlocking the mouse so that it doesn't interfere with our building. And that's all we need for that one. Alright, what's next? I'd say we can probably start actually working on the building itself. There's a few other things, but we can get to them in a little bit. So what we might do is say that, okay, if build mode is on, we're going to fire a raycast, and we're going to do that every frame. Raycast hit, build pause hit. So this is going to be the raycast that determines where we're trying to build. So if raycast, and we're going to do it from, we'll do it from the player camera dot screen point to ray, and I think we'll want it to fire from the center of the screen, I guess. So we'll say new vector 3. We'll do that easily by just saying screen dot width divided by 2. Same with screen height. So that should, in theory, be the center of the screen, and we don't need a Z value, so we'll just set that to 0. We're going to set out build pause hit. You could have whatever value you want in here for a distance. So If you want the player to be able to build from heaps far away, you would set a high value, like 20, 30 is going to be quite a lot. I'll just set it to 10 for now, just to sort of show how that works. We'll probably want a layer mask too, so we're going to be wanting to build on other cubes and the ground, so we might just quickly create a layer mask to store that. So serialize field, private layer mask, buildable surfaces layer. Oh goodness, yeah, that'll do. Okay, cool. buildable surfaces layer. Alright, cool. Blah, 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 blah. Just having a look at that. So, and I think I've got something wrong here. What's going on? One bracket too many, maybe? Nope, there we go. That's better. Alright, cool. So yeah, just make sure you actually close those brackets correctly, unlike what I did. Alright, cool. So if we fire the raycast, well, we are firing the raycast, and if it hits, then we can assume that we're hitting something we can build on, and we're hitting within a distance that we can build. So we're just going to quickly create a vector 3 to store the point at which we're hitting with the raycast. So build pos hit dot point. Easy. Alright, so we're going to now, actually we're going to need a vector 3 variable. So go back up, create a new one. It can be private, we'll just set that in a second. So private vector 3 build pos. This is going to be a vector 3 to store the position we're building in. We are going to be rounding that position. So yeah, we'll want another vector to store that. So build pos is going to equal a new vector 3 mathf.round, and we're going to round point.x. We're going to do the same for y, round, and same again for the z value, mathf.round, oops, point.z. So that's just giving us a nice rounded position to the individual units. So this sort of works on the assumption that the cubes are going to be 1 unit by 1 unit in size. You could adjust this to sort of work it out to be different units if needed, but this is just keeping it simple. And the last thing we're going to do, so we have fired a raycast, we've grabbed the point at which it hits, and we have created a nice rounded position from that point. The last thing we need to do in this is just say that can build is equal to true, which is going to just allow us a bit more control when we split this up a little bit later. And we'll want an else condition in here too. So if the raycast doesn't hit anything, what are we going to do? Well, first of all, we're going to set can build back to false. And I'm not setting build mode off because that would get annoying. If you imagine it from the player's perspective, let's say they're looking at the ground, they lift their view a little bit and it just sort of stops hitting the ground, everything's going to turn off and the cube will disappear and blah blah blah, and that's going to be annoying. So I think that's why I'm using a second build here, second ball here, is to ensure that we've got a little bit more control over just turning it off and on. We can actually still have build mode on, but still not allow the player to build, which sort of becomes a bit more important. Okay, so now that we've done all that, I think we will create another variable for, and it's going to be a game object variable, and we'll just call it current template block. So this is going to be a game object variable to store our template object when it's in the world. And I'm creating it now because we'll probably want to add in the else condition that we just created, we're going to want to actually destroy that object. So we'll just say current template block dot game object. We'll probably add in, if it doesn't equal null in there. I think it should be fairly safe the way this is going to work though. Shouldn't be a big drama. Okay, that's pretty straightforward. So the raycasting itself isn't actually spawning anything at this point. All we're doing is firing a raycast, getting the point, rounding the position, and then setting the build, like can build to true or false as needed. That should be all we really need to do in this if condition here. So after it, this is where we're going to start splitting things up a little bit. This might get a little bit confusing, but essentially what we're doing is creating a bunch of different little checks based on a couple of different conditions just to sort of see what the state of build mode is. So like I said, we can have build mode on and still not actually be able to build anything. So we might be hitting, firing a raycast and missing anything and not hitting anything. There's no template in the world, but build mode's still on. It's going to get a bit confusing. So we want to ensure that we're sort of controlling this program as best we can, and we're going to do that here. So the first thing we're going to do is the first check is going to say, alright, well if build mode's off, so if not build mode on, and the current template block doesn't equal null, so if build mode's been turned off and we still have a template block in the world, we just want to destroy it. Current template block dot game object, and we're going to set can build to false, just to ensure that, so if build mode's been turned off and the template exists, it's going to destroy it and ensure that we can't build because there's no template, so we shouldn't be able to. Makes sense. We're going to do another quick check, and we're going to say if we can build, so if can build is true and the current template block, I'm getting confused, equals null. So if for some reason can build is on and we don't have a template block in the world, we probably want to make sure that we have one. So the current template block, and this is where we're actually creating it, is going to equal instantiate, and this is where we're actually going to need those prefabs, so I should probably set those up. I don't think I have yet. No. Let's create two private game objects. What am I going to call them? So we'll have a template block. Oh, they're both, hang on. Alright, block template prefab. So this is going to be the prefab for our template block, and we're going to do one more. It's going to be a private game object, and we'll just call it block prefab. So this is actually going to be the prefab for the blocks that get created in the world. Cool. I think while we're here too, we might just quickly serialize field, and we're going to create a private material to store the template material, so that unique material that's only going to apply to the template. Alright, cool. So we actually need to create the template now. So we'll say block template prefab. We're going to create it at build pos. So this is where the vector 3 comes in. That's that rounded position, and we're just going to give it a rotation. Doesn't matter what way it's rotated. Cool. So that creates our template block that just brings it into the world and places it at the rounded position, and we just want to update its material. What is it? It's current template block dot get component. We want the mesh renderer. We want its material, and it's going to equal the template material. So that just will create the template block and update it so that it's a nice transparent blue color. Hooray! That's what we want, I think. And one final if condition. What do we need to do here? Okay, so it's pretty much the same as above, but we need to just check to see if the template block exists. So this is where we're actually doing the building part of the system. So if can build is true, so if we can build and the current template block does not equal null, so if we have a template block in the world and we can currently build, we want to make sure first of all that the current template's position is sitting on build pos, just to make sure. So it should follow the position around. So we're not spawning a new template block every time the position updates. We're simply creating the block as it's needed. So if it doesn't exist, we create it, and then we move it around as we need it. It's a little bit easier, I find. And within this check, so if the template block exists and we're able to build, we update the position, but then we're also going to say if input dot get mouse button down. I should have added that. So if the player left clicks, and we'll just create a quick function for this. We'll say place block. It doesn't exist yet. We're going to create that in a second. So once again, if you can build, if there is currently a template in the world and the player clicks, then we're gonna create a block in the world because we've got all the data we need. The template's really just a visual thing. It's just there for show. It's not doing anything. It's just moving around. And then basically, if it exists in the world, then we can assume safely that we can build and allow the player to do it. So we've got all that there. That's fantastic. Last thing that we need is just this function here, the place block function, and then we can get around to the fun stuff. We're going to assign all the variables and give it a bit of a test run. So we'll do this under update. We're going to create a new void, private void. What do we call it? We call it place block. Alright, and this is actually going to be pretty easy. All we're doing is creating a new block game object, assigning a few things to it, and ensuring that it spawns in the world. It's really easy. Here we go, game object. We'll call it new block, because I love adding the new into things to make things confusing. We're going to create it, we're going to instantiate it straight away. So the game object new block is going to equal instantiate, and we're going to spawn it from the block prefab. We're going to spawn it at build pos because we can still use that. And once again, we'll give it a rotation. As it's a cube, it doesn't matter. We're going to create a quick temporary block as well. So we'll say temp block type. We'll just call it temp block. And that's going to equal, what is it? Block sys. No, what did I call it? bsys. That's it. Dot all blocks. Now, we're going to need an ID to control this, so we'll get to that in a second. But for now, I'm just going to say 0. So the very first block, it's just going to create that in the world. We can't currently change it. We'll get to that in a second. So we're creating a new temporary block, and we're just creating it from the dictionary, the block sys dictionary, all blocks dictionary. We're going to assign the name. We'll give it a name. So the new block dot name is going to equal the temp block dot block name, and to keep it tidy we might just add something on the end, just say block. So you know, if the name is wood, it will be wood block. Simple. And finally, new block dot get component. We just need to update the mesh render as material. Oops, no, need those brackets. Material is going to equal temp block material. There you go. So just quickly, once again, we've created a new game object, we've spawned it into the world, and we've created a new block object, and using that block object, we've updated the game object's name and we've updated its material. Nice and easy. So that in theory should work. We can probably get around to assigning some variables, so I might just have a quick go at that now. Let's have a look. There's a few other things we'll need to set up as well, so hopefully I won't forget anything. And we want to assign the building system, sorry, to the manager. Cool. Alright, let's get these assigned. So the player's camera is going to be the main camera. And now we don't have the layers yet, so we might set those up now. We'll want to add 2 layers, one for the ground and one for the blocks that have already been placed in the world. So placed block, I guess. We'll assign the ground object to the ground layer, and we'll come down here to our block placed prefab, the prefab that we're using for the placed blocks, and we're going to put that one on the placed block layer. Cool. Now if we go back to that script, back to the block manager building system, we can just say that the buildable surfaces layer is going to equal the ground, and it's going to equal placed block. So when we fire that raycast, these are the 2 layers that it's allowed to hit. And we'll assign those 2 prefabs, the block template and the block itself. And finally, the template material. There we go. Cool. I think that should work. I'm going to give it a quick go. This may end hideously. Let's find out. I'll maximize that. If we press E, there we go. we're getting a nice little transparent block there. Follows our cursor around, or follows the center of the screen, and you can see if it gets too far away after 10 units, it disappears. If we click, we get the first block out of that dictionary, which is the dirt block, I believe, and that's what we can place. Nice and easy. So that's the system working. If we turn it off, we get our mouse back, and I can jump out. So that's the system. Hooray, that works. Awesome. But we do want to be able to change the blocks as well. Now it's up to you how you want to do this. You could do it with the mouse wheel, you could do it based on a UI element. It's entirely up to you. I'm going to keep it simple, just really only doing this just to show you how the int works with the dictionary. For what it's worth, I might do a tutorial covering dictionaries and hash tables in a little bit, but see how we go. And I think all I'm going to do for this, we'll want a new variable. I'd say we'll probably want an int variable, so I'll create that now. Private int block select counter. Yeah, that'll do. So it's just a counter that we're going to loop through to hold the ID for the block that we want. Where was I? It was down here. So I'm going to do that. If the player presses the R key, I think I'm just going to loop through it. So get key down, and I don't know. Like I said, you can do this however you want. And all I'm going to do is increment the block select counter by 1, and then I'm going to say that if the block select counter is greater than or equal to bsys dot all blocks dot count. So in other words, if we've reached the end of that dictionary, we are just going to make it equal 0 again, just so it sort of loops back around to the start. So you can do that however you want, but for the sake of simplicity, all I'm doing is I'm just going to increment that counter once each time you press the R key and loop back around. So if we go down now to the place block function, we can replace this 0 with the block select counter. So that should mean that we can loop through the dictionary. There's not really any visual effect to show that working at the moment, I suppose. You can add that in, call it homework, I don't know. But it's just sort of to show how that int works with it. So if I place that, I'm getting the dark brick, mostly because I pressed R by accident, so don't worry about that. If I press R again, I get the grass. You can sort of see how it's working there as well. It's sort of hitting the sides. And press R again, and it swaps again. I'll just jump out of build mode so I can get out. Actually, one thought might be, and I realized something I did do to the prefabs that I haven't shown you, that I probably should have, and you might have noticed this. If you're trying to place the blocks and they're getting stuck inside, or they're within other blocks, there may be something you need to do. So on the block placed prefab, on the prefab for those blocks, go to the box collider, and I've just found this to be the best value for my testing. You just want it to be a tiny bit more than 1. And the reason for that is, when the raycast hits, if it's a tiny bit more or a little bit over the edge or the boundaries of that block, then it's going to round to the block next to it. If that is just set to 1, you might find that you end up with the template sitting inside other blocks, and that's because it's rounding into them. So just by setting that a tiny bit more, it should work. If you find that it's sort of like jumping on top of the other block but sitting in mid-air or anything like that, just decrease this even more, chuck another 0 in there or something like that. It doesn't seem to have any functional difference that I've noticed in terms of the gameplay. It just ensures that the block system is a bit neater and a bit tidier. So if your template is jumping inside other blocks, just increase the box collider's size of the placed blocks prefab. And that should be it, I believe. I don't think I've missed anything. That's those 2 scripts. It's all up there and working. We could see that if I'll just quickly run it to show you. If we run build mode, there we go. I'll just place a couple of things down. Some blocks. Woo! Look at it. Beautiful. And cool, I'll just turn off build mode so I can have a look. You can see them all here, so it's creating those blocks appropriately. Zoom in. And each one sort of has, their box collider mesh renderer. There's not a lot more to them at this point, but you know, you could attach whatever data you want to them really, and do it within the block class or the block type struct. Doesn't matter. And you can make them however you want. But that essentially is the system working. As I said in the disclaimer, it's not the most efficient in the world. I mean, we're using a dictionary, that's kind of cool. So if you have hundreds of block types, it's going to make the lookup of that a lot easier and a lot smoother. But ultimately, you are spawning game objects into the world, and those game objects do have colliders attached to them, and they are going to get performance heavy after a while. So there are better ways to do this. The important thing was just sort of showing you how it can be done, I guess. And as always, I do hope it was useful for someone. I do appreciate you guys watching, and thank you as always for your support. Please like and subscribe if you haven't already, and I will talk to you guys next time.